I did not say crisp. I said I'll try to make it very short, which is different. So I'm going to do a very difficult exercise. My first presentation was really on a very low level before the driver, close to the hardware, and I'm going to talk about something totally different, which is at the far end of the spectrum, which is how HCNFV is using data plane. And that's the goal of this presentation. So first, a little bit of terminology. An interface is something that is defined outside any language specifics. So an interface can be implemented in C, Java, or even with a PCI protocol. So for example, there is the Vertio interface, which is actually implemented as a PCI device. So it is properly specified, and that's an interface. An API is a binding of an interface to a language or to an implementation of something. So the API itself is already a byproduct of an interface. And an implementation, as I said, is something that you may have one API, but multiple implementations of the same API. That said, I put ODP here, but that's very true for DPDK. So in DPDK and ODP, we have device APIs. We have network, so PMDs. We have crypto device APIs. We have IPsec look-aside API, and just recently added IPsec inline API. So this is good because an application can make use of some hardware capabilities, but the application is specifically using one API or the other. This means that it defeats the HCNFV vision, which is there is one application image that is instantiated on different platforms, which may have or may not have different accelerations. It may have 0 acceleration, it may have crypto acceleration, it may have IPsec look-aside, or it may have IPsec inline acceleration. So the application has to be made device agnostic. IPsec, I'm taking IPsec because that's a very simple example. The application should be made device agnostic so that it can be implemented on any platform. This is really what also Ray said earlier about the microservices. You may have microservices inside a process, in multiple processes, or multiple nodes. The API should be the same so that maybe you can spread one microservice, which is in the same process, you migrate it to a different node, and that should be working. So here, from the HCNFV standpoint, the applications have to behave like that. They should be instantiated on any hardware. So on top of those device APIs, the crypto device API, the IPsec inline device API, there should be some, let's say, network function API that is, let's do IPsec. And then depending on where it is instantiated, the actual code and implementation will be really different. It's true to the point that in HCNFV, in the IFA 002 work group, there was the IPsec interface, abstract interface defined. So this layer here is about how should we implement HCNFV, IFA 002, IPsec interface so that it can be instantiated on any of those accelerators or without accelerators. So I'm going to show how we implemented that in ODP and how we could work together to have let's say, HCNFV compliant implementation of those interfaces and how we can work with VPP2. And very briefly, to understand how we implemented it, a very brief description of how DPDK and ODP differ. DPDK, all the packets go from, let's say, the the hardware to the cores. The software does something and the packet goes out. On Open Data Plane, and if you look at the DPDK event mode, that's something a little bit similar now. You define some kind of a pipeline where the DPDK and ODP define some pipeline of functions, and the application actually controls the behavior of the pipeline. If the pipeline is entirely, let's say, made of hardware blocks, this means that we go from left to right without the CPU cores involved at all. It's all done in hardware. So in that case, if you want to look at it in a different way, ODP API is more like the merger of DPDK API and SwitchDev or SAI from Microsoft, which is controlling an autonomous hardware switching entity. So if we want to implement IPsec hardware blocks, this has been a nightmare because all the vendors have very, very, very different ways to implement IPsec. So in the pipeline, it can be before the classifier, it can be after the scheduler, or it can be even different. So to have a proper IPsec inline acceleration, this is quite a challenge. Now, if we think of when there is no acceleration, we have to have the IPsec acceleration with software queues. And if we want to leverage crypto acceleration, we also have to have a different path. So bottom line, what I'm trying to say is that this layer I presented here is not a simple, I'm lost here. The network application API for IPsec is not a simple scheme on top of the device APIs, because if you have no acceleration, you have to implement a full IPsec stack hidden below this networking API. So that's a pretty heavy component and not just a shim layer on top of that. But it's compliant with the HCNAV IFA2 specifications for IPsec. The good thing about this network application interface is that it's an interface, it's not an API. And being an interface, this means that we can continue the work of HCNAV and implement that in ODP, in VPP, in DPDK, in ways that are compatible and that are always supporting the HCNAV concepts to really deliver on the promise that one image will be instantiated on any platform and maybe even live migrated on any platform. So the message here is to go beyond the device, the individual device APIs, which are necessary. We cannot avoid them. But then we should work on a step further, which is implementing the HCNAV interfaces. This does not mean we have to share code, but at least the interface should be compatible in a way that if we have VPP on top, then the IPsec node can consume either DPDK or VPP or ODP or whatever framework is used to implement the IPsec. So here I focused on IPsec, but we have many other interface defined in Etsy. We have something called DoPFR. I don't remember what that means, but that's essentially doing the same thing as a SwitchDev or SAA from the VMs. This is to control a vSwitch, which is behind the host. So I think we are reaching, with the array comments on the microservices, we're reaching a point where the data planes have to go a little step further towards the HCNAV implementation so that VPP has a much simpler job to do when it wants to consume not just network I/O, but all the accelerators that will be here. So if we can also work together on translating this HCNAV specification in something that is actionable by all communities, that would be really efficient. And I think I'm done.
That was very efficient. Any questions for Francois Frederick? Yes.
So I kind of understand where you're trying to get to a little bit, but an interface definition is just that. I mean, it's been in all the RFCs in the world that we deal with today as far as an interface definition. But it's only trying to define what type of information needs to pass through that interface, right? Not necessarily how it's implemented or what the API looks like, right? In DPDK, we have two layers of APIs, effectively, right? The top layer API, which is generic in a lot of sense, and then the specific hardware or PMD specific APIs underneath, right? So we try to make that abstraction happen. So I'm not quite sure I understand where we're trying to go here to create yet another layer of APIs on top of current existing APIs.
Well, on both DPDK and ODP, we have on one side the crypto API. It's well defined. We know what it's handling in terms of objects. On the other side, you have IPsec, let's say inline acceleration, totally different API. It can handle many different hardware, but that's a totally different API from crypto. Now, in the case that an application wants to do something related to security, this application may want to use either crypto device, because that's what's here, or the application is using the IPsec inline acceleration. So either you push the work to be done to the application, so that the application developer have to have multiple code paths in its application to deal with either crypto dev or IPsec, or it is a framework provided function. And if this thing was just a simple shim, then the application should do it because it will be much faster. But if you want to have an IPsec service, regardless of you have crypto device or IPsec inline, you have to have on this side a full IPsec implementation.
I understand that point, but the issue is that we are developing an IPsec API to handle hardware versus software versus whatever, encompassed with the crypto dev API. So we're trying to define that already. So I still don't understand. Yes, the interface could define what type of information needs to pass from one place to the other, but it can't define what the APIs look like, and we're already trying to define that. So what do you want to change, I guess?
If we go, I don't want to change anything. I say that if we go a step further, then you have the users of that, so VPP and maybe other projects. Can they use whatever framework they want? Is this API compliant to the HCNAV specs?
Yeah, some of the people I've talked to, though, they said the application does want to know what's running underneath it. There are some people that say no. I thought that was the case, but then I got all of these other people that told me, and customers that said, no, we want to know what's running underneath us and why. So they're going to handle that piece because that's maybe their secret sauce or something. If it's a standard NFVI or VNF application that's agnostic to the world, then I agree with you. But that's not the case when we start building real applications using these pieces of framework, right? If you have DPDK in the VNF, then it's going to build itself specifically for how you deal with those different accelerated hardware underneath it. That's what I've been told.
So I would say I can't say for all the market, but at least from a number of those companies listed here, that's what they asked me to do. So
okay, I understand.
I'm trying to cross the links.
Okay, well, I think there's more definitions there, because I think we already have a common set of APIs in DPDK. We just need to figure out why we have to continue to define them as far
But
as the...
maybe we can continue offline. I don't want to steal too much time for the other speaker.
Thank you, Francois.
Thank you very much, all.